Thank you all for being here. Before the break, we're going to spend some time talking a little bit about and showing you some of the innovations that we are building in the data platforms organization. And if I were to give you like one big guess, what do you think I'm going to talk a little bit about first? Anyone? AI maybe? Kind of important. So I want to talk about what is driving us and what we think about in how we're investing, optimizing, building software inside of the data platform. Because certainly all of the great and amazing things that we've seen, applications and demos and drinks last night, other keynote speakers, all of those applications are really driven by that digital backbone that Don mentioned. And making those outcomes be relevant is our mission inside of the data platform team. So if you turn on CNBC or any news program or read your even local paper, you might be seeing some of the headlines that are here. AI is great, but it's using a lot of power. And its demands on infrastructure, natural resources, not just power, but even water for cooling of some of these things is extreme. And you can see here from the World Economic Forum, kind of before AI, we had this trend of, using natural resources for compute power. And now with the advent of AI and the extreme demand that creates, you can just see that we're skyrocketing in terms of the amount of resource required to deliver on the promise. And on this scale, this only goes to 2035, which is really not that far away. In fact, in my hometown, which is very close to the nuclear reactor 3 Mile Island, you may remember it was shut down because of a big safety issue. It's been reopened solely to power a data center from one of the hyperscalers. So these demands are real, and keeping up is going to be difficult. Well, I've seen this kind of curve before, and I think this leads to the point that I want to make about how AI is going to be demanding of not just hardware, not just power, but really intelligent software and better data management opportunities. So if you remember, the Pentium processor, which was so game-changing in so many ways, kind of started out, powering desktop computers, laptop computers, and of course the demands of new applications, things like Windows operating systems, and so on, required more and more processing power locally. And so, of course, Intel added transistors to make things run faster, but also started to increase the clock speed of these processors to give us more of what we demanded. And that worked really well because as you increase the clock speed, you simply got more stuff done more quickly. Applications ran faster. You're able to build more sophisticated things on the desktop. And that was all really good, except that it started to get really hot. And so remember, those early desktops had big fans in them to kind of cool. And if you look at the trajectory of what technology would provide and what applications would demand, that heat curve became extremely unsustainable to the point that it would have, in the year 2000, made that chip hotter than the surface of the sun. Kind of hard to package that in a laptop, right? So, well, what happened? Of course, that was not sustainable. Kind of like the power curve I showed on the previous chart. But what happened was there was this innovation called multi-core. So instead of having the clock go faster, Intel just gave us more cores. And so that solved the heat problem while still being able to deliver on the cycles required for processing the software. Okay, that's really great. But it wasn't just the hardware, because in this environment, software had to be very sophisticated to take advantage of not a single thread running faster, but now how do I distribute all of that work across multiple threads to take advantage of those transistors? And many software vendors at the time struggled to get any benefit out of multi-core. So it required great hardware innovation and great software innovation to take advantage of what was happening. So another thing to think about, kind of having seen this play before, where we have increasing demand and need to be really smart about how we deliver it, is smartphones. We all have, I had to put mine on the table, but we all have our smartphones, right? And think about in the early days of cell phones, gosh, I remember if I could get like an hour out of the battery, that was great. And so there was all this demand, just like the demand for AI. So what happened? Well, of course, we put bigger batteries in, but in the smartphone age, with these big screens, we had these refresh rates that started out in some of the earlier ones at 60 hertz display, right? But of course, we wanted to see streaming video, and we didn't want it to skip around. So of course, we went to 120. Well, what happened? Battery only lasts half as long. Not a good outcome considering the demand. So of course, in the current generations of all the phones that certainly most of us in this room have today, something very sophisticated happened, and that is only updates the pixels that need to change at the time that they need to change, instead of a full screen refresh, and voila, the battery lasts the better part of a day. Better performance, more sophisticated, because you're only touching the data that needs to be touched at the time that that data needs to be touched. So again, solved the problem of demand and made it more efficient in processing. So my point behind this history lesson is not to bore you with how old I am and how these trends are, but in fact to say the AI demand is a play that we've seen before. And to really go solve this, it is going to require innovation in hardware. And of course, we all regale with the latest releases from chip manufacturers, and that's great. But it's also going to require smart software that can take advantage of these processors. And it's going to require very sophisticated smart data access to only touch the data that are required, not scan the entire internet to get an answer every time, perhaps. Only touch the data that are required and move the data as infrequently as possible to help solve that overall demand that we see on natural resources coming from AI. So in the end, the way we think about it in Iris Data Platform is how do we really enable better models, cleaner data, and optimized processing to really deliver on that promise for AI. And so what you see is that we really focus on 4 key areas for the difference and the different by design that I talked with you all about last year inside of Iris. First, we really do try to move the processing to the data. Remember, data movement takes energy, it creates latency. Sometimes the data doesn't get there properly, so there's also kind of the cleanliness factor of it. And of course, there's also the notion of privacy and security. So our software is designed with the intent of being able to have you move the processing to your data instead of having to move and have multiple copies of data all in everywhere. Of course, we support any kind of data and any analytics, so you're not restricted to the kinds of analysis that you want to do. Of course, AI is a very sophisticated tool that we're all seeing the benefit of in our daily lives today, but it's not the only tool. Machine learning algorithms are still extremely valuable. Deep learning algorithms extremely valuable. A lot of our organizations still depend on traditional business intelligence. So being able to do kind of any data, any structure, and any analytic in one place. We do all of this with limitless scale in terms of the size of data that you deploy, the size of application clusters that you deploy, and we'll talk a lot more about some of those new advances in the software in the afternoon breakout sessions. And finally, we provide an unparalleled sophisticated interoperability engine built into the product. So it's not a bolt-on, it's not something you have to think about separately. It's guaranteed delivery and it's highly efficient. And so in these ways, what we've seen when we look at our deployments for analytics, you can actually deploy leveraging InterSystems Iris with a much smaller carbon footprint, with much less power, heating, and cooling required, because you're moving the processing to the data. You don't have to have multiple setups, multiple copies of the data. You don't introduce all that latency, and you can scale at any level that you need to scale to. So this is what drives us. You're going to actually see later here this morning before the break a couple of examples.